Hello students. So today I am doing class for class 12 science. The topic is inverse of a matrix. So in the last online class also we were doing the same inverse of a matrix. This was the topic. So we were doing how to solve a given system of equations by matrix inversion method. So this is the continuation part. Okay. The question is question number 7. Same exercise is there. Exercise 3, that is page number. The page number is 214, right? So each question section is each question carries 5 marks. So question number 7. Let's do question number 7 now. If capital A is equal to, third order matrix is given out here, 3 into 3 matrix. First row is 2 minus 3, 5. Second row is 3, 2 minus 4, and the third row is 1, 1 minus 2. You have to find out A inverse. You have to find out the matrix A inverse, and hence you have to solve the given linear equations, that is 2x minus 3y plus 5z is equal to 11, 3x plus 2y minus 4z is equal to minus 5, and x plus y minus 2z is equal to minus 3. So first of all you have to get the matrix A inverse, and hence you have to solve the given system of equations. Okay, so this is the given matrix, right? So for this given matrix, in order to get A inverse, you have to find out det A, and det A should not be equal to 0, right? So therefore let us find out det A first. Det A is equal to, let us convert into determinant form, 2 minus 3, 5, 3, 2 minus 4, 1, 1 minus 2, right? So therefore, so what is det A now? So now we can expand it. So this is the determinant form. This is the determinant. It should be all the elements should be enclosed within vertical lines. So this is the determinant. We have converted into determinant form. That means you can expand it. We can expand it with respect to the first row. Plus minus plus. So plus 2. Now delete the row and the column through the element 2. First row and first column are deleted. What remains? 2 minus 4, 1 minus 2. So cross multiply. 2 into minus 2, minus 4. Then it is plus 4, right? Minus 4 plus 4. Then comes minus. So minus to minus, plus 3. Now delete the row and the column through the element minus 3. So it remains 3 minus 4, 1 minus 2. 3 into minus 2, minus 6 plus 4. Then comes plus 5, plus 5. If you take this 5, you can delete the row and the column through the element 5. That is first row and third column are deleted. What remains? 3, 2, 1, 1. So it is 3 ones are 3 minus 2. Right? So which is equal to 2 into 0. This is 0 plus 3 into, this is your minus 2 plus 5 into 1. Which is equal to 0 minus 6. It is 0 minus 6 plus 5, which is equal to minus 1. So it is not equal to 0. That means A inverse exists. So A inverse exists. So is that clear to all of you? So now, so in order to get A inverse, you should find out the adjoint of A. In order to get the adjoint of A, you should know the cofactors of each elements of the matrix A, right? So let us find out cofactors of each elements of matrix A, right? Now, capital A11. What is capital A11? You know that. Capital A11 denotes the cofactor of the element belonging to the first row and first column. So, first row and first column, that means 2. You have to find out the cofactor of 2. You have to consider the sign also. So how can you consider the sign? Minus 1 whole to the power 1 plus 1 into. Now, delete the row and the column to the element 2. What remains? 2 minus 4, 2 minus 4, right? 2 minus 4 and 1 minus 2. So it is 1 minus 2. So which is equal to, you can simplify it further. What is minus 1 over square? It is plus 1. Usually we don't write it. So then minus 4 plus 4, which is equal to 0. So that is your A11. Next, you have to find out A12. That means cofactor of the element belonging to the first row and second column. First row and second column, that means minus 3. You have to find out the cofactor of minus 3. So it is minus 1 whole to the power 1 plus 2. Right? Now delete the row and the column through the element minus 3. First row and second column are deleted. What remains? 3 minus 4, 1 minus 2. 3 minus 4, 3 minus 4, 1 minus 2. 1 minus 2. Okay? Which is equal to, what is minus 1 whole cube? Minus 1. That means write only minus sign. Within bracket, you can cross multiply it. You can expand the second order determinant. That is 3 into minus 2, minus 6 plus 4. Which is equal to 2. Minus 6 plus 4 is minus 2. So minus and minus plus 2. Then comes A13. First of all, consider the sign minus 1 whole to the power 1 plus 3. A13 means you have to find out the cofactor of the element belonging to the first row and third column. First row and third column, that means 5. So delete the row and the column through the element 5. First row and third column are deleted. 3, 2, 1, 1. So it is 3, 2, 1, 1. It is 3, 2, 1, 1. So which is equal to minus 1 to the power 4 is plus 1. So what do we get after expanding this? 3 minus 2 is equal to 1. 3 ones are 3 minus 2, which is equal to 1. Then comes A21. Consider the sign first. Minus 1 to the power 1 plus 2. Right? A21 means you have to find out the cofactor of the element belonging to the second row and first column. Second row and first column. That means 3. Now, what is the cofactor of 3? Minus 1 to the power 2 plus 1. Now, delete the row and the column through the element 3. First row, first column and second row are deleted. Second row and first column are deleted. What remains? Minus 3, 5. Minus 3, 5. Then 1 minus 2. 1 minus 2, right? Which is equal to, what is minus 1 to the power 2 plus 1? It is minus. So within bracket, minus into minus plus 6 minus 5. Which is equal to minus 1. You know how to expand it, isn't it? So next one is A22. First consider the sign minus 1 to the power 2 plus 2. Now A22 means you have to find out the cofactor of these two. Delete the row and the column through the element. Second row and second column are deleted. 2, 5, 1 minus 2 remain. 2, 5, 2, 5, 1 minus 2. 1 minus 2, right? Which is equal to, what is minus 1 to the power 4? That is plus 1. So we don't write it. So it is minus 4 minus 5 is equal to minus 9. Clear? Next, A23. Next, you have to find out A23. That means cofactor of the element belonging to the second row and third column. So first of all, consider the sign minus 1 to the power 2 plus 3. Now, element, cofactor of the element belonging to the second row and third column. Second row and third column. Second row and third column. That is minus 4. Right? So delete the row and the column through the element minus 4. Third row and third column and second row are deleted. What remains? 2 minus 3, 1, 1. 2 minus 3, 1, 1. Which is equal to, what is minus 1 to the power 5? What is minus 1 whole to the power 5? That is your minus, isn't it? So it is minus within bracket 2 plus 3, which is equal to minus 5. So it is 2 ones are 2. Then minus to minus plus 3. Okay? So this is your A23. Now here, so date A is minus 1 here. Let us write it here. Date A is equal to minus 1. Right? Next, you have to find out what is to be found out. That is A31. So what is A31? Cofactor of the element belonging to the third row and first column. Third row and first column. That means 1. You have to find out the cofactor of 1. So let us consider the sign first. Minus 1 to the power 3 plus 1. Delete the row and the column to the element 1 now. So it remains minus 3, 5. minus 3, 5, 2 minus 4. Right? Which is equal to, what is minus 1 to the power of 4? It is plus 1. So it is minus into minus plus 12, minus 2 into minus 4, 12, then minus 10, which is equal to 2. So that is your A31. Next is A32. First of all, consider the sign minus 1 over to the power of 3 plus 2. So you have to find out A32. That means cofactor of the element belonging to the third row and second column. Third row and second row. That means 1. You have to delete the row and the column through the element 1. That means second row and third row and second column are deleted. So it remains 2, 5, 2, 5, 3 minus 4. 3 minus 4, right? So which is equal to, what is minus 1 over to the power of 5? Minus, so it is minus 8. Minus 8, isn't it? 2 into minus 4, minus 8, then minus 15. Which is equal to, this is your plus 23. Clear? Then comes A33. So minus 1 whole to the power 3 plus 3. Now we have to find out the cofactor of the element belonging to the third row and third column. Third row and third column, that is minus 2. You have to find out the cofactor of minus 2. The sign is minus 1 whole to the power 6. So delete the row and the column through the element minus 2. Third row and third column are deleted. So it remains 2 minus 3, 3, 2. So which is equal to, what is minus 1 over to the power 6? It is plus 1. So it is 2 2s are 4 plus 9, isn't it? 2 2s are 4, minus 1 minus plus 3 3s are 9. Which is equal to 9 plus 4 is 13. So I think you have understood it. Okay. Now what do we write? Let B be the matrix. Let B be the matrix. Let B be the matrix whose elements are the cofactors. Whose elements are the cofactors of the elements of matrix A. Right? So now here, let us write down the value for A11 here in the rough part. Okay, I will write it here. What was A11? A11 is equal to 0. What is A12? It is 2. What is A13? It is 1. What is A21? It is minus 1. And what is A22? A22 minus 9. And A23 is equal to minus 5. Okay? A11 is 0. A12 is 2. A13 is 1. Then A21 is minus 1. A22 is minus 9. And A23 is minus 5. Now I will draw it. Now we have to write down the matrix B. What is matrix B? Let B be the matrix whose elements are the cofactors of the elements of matrix A. So matrix B is equal to, you have to write down the cofactors of the elements of matrix A in the matrix form. So A11, A12, A13, A21, A22, A23, A31, A32, A33, right? So therefore, what is capital B now? So what was A11? A11 was 0. What is A12? A12 is 2. What is A13? It is 1. What is A21? It is minus 1. What is A22? Minus 9. What is A23? Minus 5. A23 is minus 5. And what is A31? A31 is 2. Right? What is A32? It is 23. It is 23. And next A33 is what? 13. It is 13, right? So we got the matrix B. So how can you find out the adjoint of A? So ADJ A is equal to B transpose. That means you have to change rows into columns and columns into rows in matrix B. So what is capital B out here? Now first column becomes the first row, 0, minus 1, 2. Second column becomes the second row, 2, minus 9, 23. Then third column becomes the third row here, 1 minus 5, 30. Right? So this is adjoint of A. This is your adjoint of A. So we have got the adjoint of A, right? So now what is to be determined here? So you have to determine A inverse. You have to get A inverse, right? So how can you get A inverse now? So you have to get A inverse. What is the formula? A inverse is equal to 1 upon det A into ADJ A, right? Or A inverse is equal to 1 upon, what is det A? Det A is minus 1, right? Then what is ADJ A? What is ADJ A? 0, minus 1, 2, 2 minus 9, 23, then 1 minus 5, 1 minus 5, 13, right? So 1 upon minus 1 is minus 1. So you can multiply all the elements of the matrix by minus 1, isn't it? So that you can have A inverse. So which is equal to minus, multiply all these elements of the matrix by minus 1. So what do we get? 0, 1, minus 2. This is minus 2, 9, minus 23. And this is minus 1, 5, minus 13. So we got the matrix A inverse. Is that clear to all of you? So we got the matrix A inverse. And so now hence you have to solve the given system of equations, isn't it? So what is the given system of equations here? The given system of equations. Now given system of equations is, it was 2x minus 3y, 2x minus 3y plus 5z equals 11. Then 3x plus 2y, 3x plus 2y minus 4z is equal to minus 5, right? 2x minus 2y plus 5z is equal to 11. 3x plus 2y minus 4z is equal to minus 5. And x plus y minus 2z. X plus y minus 2z is equal to, what is it? X plus y minus 2z is equal to minus 3. It is minus 3. So all the constant term are on the right hand side. So it's okay, right? And so now we have to write down the coefficient matrix. So A is equal to, let capital A is equal to, what is the coefficient matrix here? You have to write down the coefficient of x, y and z from equation 1 in the first row. That is 2 minus 3, 5, right? So it is 2 minus 3, 5. Next, 3, 2 minus 4. 3, 2 minus 4. And then 1, 1 minus 2. 1, 1 minus 2. This is the matrix A. Now, you have to write down the column matrix. Which is the unknown matrix? Let x is equal to, let capital X is equal to, which are the unknown quantities? It is x, y, z, right? And this is the constant matrix, that is C. Let capital C is equal to, what is it? It is 11 minus 5 minus 3. This is the constant matrix, that is 11 minus 5 minus 3. That is the column matrix, right? So now this linear equations now can be converted into matrix equation. What is the matrix equation here? Therefore Ax is equal to C. You can take A to the right hand side, or capital X is equal to A inverse C, or capital X is equal to, what is A inverse? Just now we got the matrix A inverse. Let us write it. What is it? 0, 1 minus 0, 1 minus 2, right? Then minus 2, 9, minus 23, next third row, minus 1, 5, minus 1, 5, minus 13, minus 1, 5, minus 13, that is A inverse. Now what is constant? What is the constant matrix here? That is 11 minus 5, 11 minus 5, then minus 3, right? So these are the matrices. Now you can easily multiply it. For the first matrix, how many columns are there? 3 columns. And for the second matrix, how many rows are there? 3 rows. That means number of columns is your number of rows. You can easily multiply them. Or capital X is equal to. Now first row by first column. 0 into 11, 0. Then comes minus 5. 0 into 11, 0. Right? 0 into 11 is 0. Then minus 5. Then plus 6. 0 into 11, 0. 1 into minus 5, minus 5, minus 2 into minus 2 into minus 3, plus 6. Next, second row by first column, minus 22, minus 45, right? Then plus 69, isn't it? Minus 2 into 11, minus 22, 9 into minus 5, minus 45, minus 23 into minus 3, that is plus. Minus 2 minus plus, 3 3 is 9, 3 2 is 6, that is 69. Then, third row by first column, minus 11, 11 into minus 1, minus 11, 5 into minus 5, minus 25, then minus 2 minus plus, 39 is 33 is 39. Is that clear? Minus 13 into minus 3 is plus 39. Or, now capital X is equal to, this is 6 minus 5, 1. This is minus 67 plus 69. Right? So it is minus and minus plus 39. Right? So now it is minus 26. Minus 36. Minus 27 and then minus 36 plus 39. And now actually what was capital X? Capital X was small x, y, z, that is the column matrix, which is equal to 1, 69 minus 67, 2, 39 minus 36, 3. So you know from the definition of equality of two matrices, from the definition of equality of matrices, you can equate the corresponding elements. So that is x is equal to 1, y is equal to 2, and z is equal to what? It is 3. So this is the final answer. So you can copy it. We'll do the next question now. Now we'll do the next question, that is question number 8. From the matrix equation Ax is equal to B, find X. Given A is equal to this matrix and B is equal to that column matrix. Okay. So from Ax is equal to B, you have to find out X. That is, what is the given matrix equation here? Your given is Ax is equal to B. So therefore X is equal to, when A is taken to the right hand side, it becomes A inverse B. That means you have to find out A inverse. Okay. Now let us find out det A first. So det A is equal to, you have to convert into determinant form 1 minus 1 0, then 0 1 minus 1, and then 1 1 1, right? So you can expand it with respect to the first row. So det A is equal to, expand it with respect to the first row now, plus minus plus, isn't it? So plus 1. So within bracket, delete the row and the column to the element 1. First row and first column are deleted. So it remains 1 minus 1 1 1. So 1 1s are 1. Minus into minus, plus 1, right? Then again, minus sign is there. Minus into minus, plus 1 within bracket. Delete the row and the column through the element minus 1. So what remains? 0 minus 1, 1, 1. So 0 1s are 0. Then it is minus into minus, plus 1. Okay? Plus 0 will be there, but will you write 0? No, because 0 into any number is always 0. So you don't have to write 0 out there. So which is equal to, how much is it now? 1 plus 1, 2. 2 1s are 2, plus 1 which is equal to 3, it is not equal to 0. That means A inverse exists. That means A inverse exists. Is that clear? So now let us find out A11. So now what is A11 here? Minus 1 whole to the power 1 plus 1, you know how to get it. A11 is equal to, you have to consider the sign. A11 means cofactor of the element belonging to the first row and first column. Consider the sign. Minus 1 whole to the power. This suffix 1 is there. You have to write in the power 1 plus 1. Now, first row and first column. First row and first. That means 1. You have to find out the cofactor of 1. Delete the row and the column through the element. That means first row and first column are deleted. What remains? 1 minus 1, 1, 1. So this is 1 minus 1, 1, 1. Right? So simplify it. What is minus 1 whole square? Plus 1. So which is equal to, expand the determinant, second order determinant, 1 ones are 1 plus 1, which is equal to 2. That is A11. Next, A12. So minus 1 whole to the power 1 plus 2. You have to consider the sign. Now get the cofactor of the element belonging to the first row and second column. First row and second column. That means minus 1. You have to delete the row and the column through the element minus 1. First row and second column are deleted. So 0 minus 1, 1, 1. 0 minus 1, 1, 1. Right? 0 minus 1, 1, 1. Okay? So is equal to, this will be minus sign because minus 1 whole cube is minus, and within bracket 0. Right? 0 1 is 0. So minus and minus plus 1, which is equal to minus 1. Next one is A13. Now consider the sign first. Minus 1 whole to the power 1 plus 3. Minus 1 whole to the power 1 plus 3. Right? Now A13 means cofactor of the element belonging to the first row and third column. First row, that is first row and third column. First row, third column, first row, third. That means 0. You have to find out the cofactor of 0. We have already considered the sign. Now delete the row and the column through the element 0. First row and third column are deleted. What remains? 0 1 1 1. 0 1 1 1, which is equal to. So what is minus 1 whole to the power 4? That is plus. So it is 0 1 is 0 minus 1, which is equal to minus 1. Right? And next comes A21. So what is meant by A21? That is cofactor of the element belonging to second row and first column. Second row and first column. That means 0 again. So you have to consider the sign minus 1 to the power 2 plus 1. Now delete the row and the column through the element 0. That is second row and first column are deleted. What remains? Minus 1 0 1 1. Minus 1 0 1 1, which is equal to, what is that? Minus 1 whole to the power. What is minus 1 whole to the power 3? That is minus. Right? Minus. So within bracket we have minus 1 minus 0, which is equal to plus 1. Next comes A22. Minus 1 whole to the power 2 plus 2. Now A22 means element, cofactor of the element belonging to the second row and second column. Second row and second column. That means 1. You have to find out the cofactor of 1. So it is minus 1 whole to the power 2 plus 1. Delete the row and the column through this one. Second column and second row are deleted. 1 0 1 1. 1 0 1 1, which is equal to, what is minus 1 whole to the power 4? That is plus 1. So it is 1 1 are 1 minus 0, which is equal to, this is 1. Right? Next, A23, which is equal to minus 1 whole to the power 2 plus 3. Okay? Now A23 means cofactor of the element belonging to the second row and third column. Second row and third column. That is minus 1. You have to find out the cofactor of minus 1. So delete the row and the column through the element minus 1. That is second row and third column are deleted. 1 minus 1 1 1. 1 minus 1 1 1. So which is equal to, what is minus 1 whole to the power 5 minus, within bracket 1 1s are 1 minus 2 minus plus 1, which is equal to, this is your minus 2. So I think I've understood it. Okay. Now let us write down det A out here. What is det A is equal to? Det A is equal to 3. That is det A is equal to 3, right? Next, let us find out A23. We have got A23. Now A31. Minus 1 whole to the power 3 plus 1 into. A31 means cofactor of the element belonging to the third row and first column. Third row and first column, that is 1. You have to find out the cofactor of 1. Now delete the row and the column through the element 1. Third row and first column are deleted. Difference minus 1, 0, 1, minus 1. Minus 1, 0, 1, minus 1. Which is equal to. What is minus 1 to the power 4? It is plus, right? So minus 2 minus plus 1 minus 0 is equal to 1. Right? Next one is A32, which is equal to minus 1 whole to the power 3 plus 2. Now A32 means cofactor of the element belonging to the third row and second column. Third row and second column. That means 1. You have to find out the cofactor of 1. We have already considered the sign. So delete the row and the column to the element 1. That means third row and second column are deleted. What remains? 1, 0, 0, minus 1. 1, 0, 0, minus 1. Which is equal to minus. It is minus 1 minus 0, which is equal to plus 1. Is that correct? Minus 1 to the power 5 is minus. Within bracket 1 into minus 1 is minus 1 minus 0, which is equal to plus 1. Next one is A33. So A33 is equal to, what is it? What is A33 now? It is minus 1 to the power 3 plus 3. Now what is A33 here? Cofactor of the element belonging to the third row and third column. Belonging to the third row and third column, right? So which is the element here? This is third row and third row. Third row and third row. That means this is 1. You have to delete the row and the column to the element 1. That means third row and third column are deleted. What remains? 1 minus 1, 0, 1. 1 minus 1, 0, 1. Which is equal to, what is minus 1 to the power 6? It is plus 1 always. So it is 1 1s are 1 plus 0, which is equal to 1. Is that clear? So now you have to write down the matrix B. So let capital B be the matrix. So all the 9 elements, we have found out the cofactors of all the 9 elements of the matrix E. So let capital B be the matrix. Let capital B be the matrix whose elements are the cofactors. Whose elements are the cofactors of the elements of matrix A. Of matrix A, right? So therefore capital B is equal to, this is A11, A12, A13, A21, A22, A23. Then comes A31, A32, A33. So these are the cofactors of the elements of matrix E. Or what is B now? So capital B is equal to, what is A11? It is 2. What is A12? It is minus 1. What is A13? It is also minus 1, isn't it? 2 minus 1 minus 1. Then what is A21? 1. What is A22? It is 1. What is A23? It is minus 2. Right? And then comes A31. What is A31? 1. What is A32? That is also 1. And what is A33? That is also 1. So this is the matrix B. So now what is to be determined? You have to find out what is to be determined now. You have to find out the adjoint of A. So what is adjoint of A? Adjoint of A is determined by the transpose of the matrix B. So you have to find out transpose of the matrix B. So det A was 3, right? Det A was 3. So find out adjoint of A now. So A is A is equal to B transpose. Okay. So A is equal to, what is B transpose here? You have to change rows into columns and columns into rows. Now this 2, 1, 1, first column becomes the first row here. This second column becomes the second row here. And this third column becomes the third row here. -1, -2 and 1. So this is your adjoint of A. Now we have to find out A inverse now. So what is A inverse? What is the formula? 1 upon det A into A is A. 1 upon det A into matrix or matrix adjoint of A. Right? So or A inverse is equal to 1 upon 3. Then write down the adjoint of A. What is the adjoint of A? 2, 1, 1, -1, 1, 1, -1, -2, 1. So this is the inverse of the matrix A. Now we have to find out the matrix capital X, isn't it? So let us find out the matrix capital X. So what was capital X actually? So here capital X was A inverse B. So or this B is the given matrix from the equation, not this matrix B, right? This matrix B is given in the question, but not this matrix B. But it is not this matrix B, okay? This matrix B is given in the question. Or capital X is equal to, what is A inverse here? 1/3. It is 2, 1, 1. 2, 1, 1. Then -1, 1, 1. Then -1, -2, 1. Right? And what was the matrix B now? So here the matrix B is, it is 2, 1, 7. It is 2, 1, 7. Now let us find it. So you can multiply these two matrices, right? So let us multiply them, or capital X is equal to 1/3. Now multiply these two matrices, first row by first column. 2 2s are 4 plus 1 1s are 1 plus 7. Then again second row by first column, -1 into 2, -2, 1 1s are plus 1 plus 7. Right? Then comes what? Then comes third row by first column, -1 into 2, -2, -2 into 1, -2 plus 7. Right? Or what is capital X here? 1/3, 7 plus 1, 8, 8 plus 4, 12. 7 plus 1, 8, 8 minus 2 is 6. 7 minus 4 is 3. Right? Now, since here capital X is equal to, now in the column matrix it is given 12, 6, 3. The numbers are 12, 6, 3. So all these elements of the matrix is multiplied by the scalar quantity, that is 1/3. So what is capital X now? How much is it? 1/3 into 12, 3 4s are 12. 1/3 into 6, 3 2s are 6. 1/3 into 3, that is 1. So this is the final answer. That means we got the matrix X. Is that clear? So now we'll do question number 11. So the given matrix is, if A is equal to 1/3 and the matrix given here is third order matrix, you have to find out A dot A transpose. That is, AT is A transpose, and hence you have to find out A inverse. So using A dot A transpose, you can find out A inverse here. So let us find out A dot A transpose first. What is A here? It is 1/3. 1 2 2 2 1 minus 2 minus 2 2 minus 1. That is your A. Into what is A transpose? 1/3 remains same. But what is A transpose? You have to change rows into columns and columns into rows in matrix A. That means now first column becomes the first row here, 1 2 minus 2. The second column becomes the second row, 2 1 2, and this third column becomes the third row here, 2 minus 2 minus 1, right? So let us multiply them. Is equal to 1/3 into 1/3, 1 by 9. You know how to multiply it. First row by first column, 1 1s are 1, plus 2 2s are 4, plus 2 2s are 4. Again, first row by second column, corresponding elements should be multiplied. 1 2s are 2, plus 2 1s are 2, minus 4, right? Again, first row by third column, minus 2, plus 4, minus 2. Is that clear? Next, second row by first column, 2 1s are 2, plus 2 1s are 2, minus 4. Again, second row by second column, 2 2s are 4, plus 1, plus 4. Again, second row by third column, 2 into minus 2, minus 4, plus 2, plus 2. You know how to multiply them, right? Now, third row by first column, corresponding elements should be multiplied. Minus 2 into 2, minus 2, plus 4, minus 2. Next, third row by second column, minus 2 into 2, minus 4, plus 2, minus to minus, plus 2, right? Next one is third row by third column, minus 2 into minus 2, plus 4, plus 2 2s are 4, minus to minus, plus 1. So we got this matrix, which is equal to 1/9. So next one is, this is 9, right? It is 9 0 0. Okay, this is 0 9 0 0 9 0, and next this is 0 0 9 0 0 9, right? So we got this matrix. Now that all the elements of the matrix can be multiplied by the scalar quantity, that is 1 by 9, that is constant. So all the elements will be multiplied by 1 by 9. So what do we get? 1 0 0 0 1 0, that is 0 0 1. That means we got the identity matrix. That means A dot A transpose is equal to I. Got it? So we have found out A dot A transpose is equal to I, and hence you have to find out A inverse. So let us find out A inverse now. So how can you get this A inverse now? So we have just now proved that A dot A transpose is equal to I. So in order to get A inverse, let us take this A to the right hand side. So it is A transpose is equal to A inverse dot I, or A transpose is equal to, what is A inverse dot I from the properties of matrices? A inverse dot I is always A inverse, or you can write A inverse is equal to A transpose. Or what is A inverse now? A inverse, what is A transpose? It is 1/3. So in the given matrix A, you change rows into columns and columns into rows. What do we get? 1 2 minus 2 becomes the first row now. This first column becomes the first row here. This second column becomes the second row here, and this third column becomes the third row here. 2 minus 2 minus 1. So this is the final answer. So I think I've understood it. Now we'll do the next question now. So now we'll do the next problem, that is question number 13. Use the product 1 minus 1 0 2 3 4 0 1 2 cross. Again the second order matrix is given, 2 2 minus 4 minus 4 2 minus 4 and 2 minus 1 5. So use this product to solve the following system of equations. X minus y is equal to 3, 2x plus 3y plus 4z is equal to 17, and y plus 2z is equal to 7. You have to use the product of these two matrices to solve this given system of equations. So this is another type of problem to solve the given system of equations. Okay. So let us assume, let capital A is equal to 1, minus 1, 0, 2, 3, 4, and this is 0, 1, 2. Alright. So this is just like your coefficient matrix of the given system of equations. That is 1 minus 1 is here. What is the coefficient of x here? 1. Coefficient of y is minus 1. So it is 1 minus 1 and z is not there, so it is 0. From the second equation, what are the coefficient of x, y, z? 2, 3, 4. This is also 2, 3, 4. So from the third equation, what are the coefficient of x, y, z? Since there is no x term there, this is 0. This 0, coefficient of y is 1 and the coefficient of z is 2. So let us assume this matrix as A and B is equal to, and what is B here? So what is B now? 2, 2, minus 4, minus 4, 2, minus 4, then 2 minus 1, 5. Right? So let us find out the product. Therefore, AB is equal to, what is A here? 1 minus 1, 0. This is 2, 3, 4. Then 0, 1, 2. Then the next one is, what is B? 2, 2 minus 4. It is minus 4, 2 minus 4. It is 2 minus 1 and it is 5. So let us multiply them. Right? So let us multiply it. So which is equal to, you can multiply these two matrices. Now first row by first column. Corresponding elements should be multiplied. So what do you get? 1 2s are 2, minus 1 into minus 4 plus 4. Right? This is 1 2s are 2 plus 4 plus 0. Right? Next, first row by second column. 1 2s are 2, minus 2, minus 0. Next, first row by third column. Minus 4. It is minus 4. Minus 1 into minus 4 plus 4. Then 0 into 5 is 0. Got it? Now second row by first column. 2 2s are 4. Then 3 into minus 4. 3 into minus 4 is minus 12. Right? Plus 4 2s are 8. Next, second row by second column. 2 2s are 4 plus 6 plus 6, then minus 4. Then minus 4. Right? Next one is second row by third column. Minus 8, minus 8, minus 12, then plus 20, then plus 20, right? Next, third row by first column. 0 2s are 0, 1 into minus 4, minus 4, plus 2 2s are 4, right? Again, second row by second column, third row by second column. 0 2s are 0, 1 2s are plus 2, 2 into minus 1, minus 2, right? Next, third row by third column. 0 into minus 4, 0, 1 into minus 4, minus 4, 2 into 5, that is plus 10. Matrix sign is closed now. So I think you have understood it. So which is equal to next? So it is 6, 0, 0. This is also 0, 6, 0. This is also 0, 0. That is 10 minus 4 is 6. So we got this relation, right? So if you find out the product of A and B, what do we get? We get 6, 0, 0, 0, 6, 0, 0, 0, 6. Now, we got, that is, which is equal to, what is common here? 6. So it is 1, 0, 0, then 0, 1, 0, and it is 0, 0, 1. Right? which is equal to 6i. So we got 6i, that is AB is equal to 6i, right? So now we got AB is equal to 6i. Actually, you have to get the value for matrix A inverse, right? So multiply both the sides by A inverse AB is equal to 6 A inverse I. What is A inverse A? IB is equal to 6. What is A inverse into I? That is your A inverse. What is IB? That means B is equal to 6A inverse. Okay. Now what is 6A inverse? What is 6A inverse is equal to B? That is A inverse is equal to, what is it? That is A inverse is equal to 1 by 6 into matrix B. So it is just like solving A inverse. So A inverse is equal to, when this 6 is taken to the left hand side, you should write in the denominator. That is 1 by 6 into B. So, or what is A inverse now? Which is equal to 1 by 6. And what is B out here? B matrix was 2, 2, minus 4, minus 4, 2, minus 4, and then it is 2, minus 1, 5. Is that clear? So this is the matrix A inverse. That is, inverse of the matrix A is this one. Okay? So now, you have to solve the given system of equations. So given equations are, so write down the given equations. What is the given equation out here? So the given equation is, so write down the given equation, that is x minus y is equal to 3. That is x minus y is equal to 3. That is number 1. Next one is 2x plus 3y plus 4z is equal to 17. That is number 2. And the next one is y plus 2z is equal to 7. That is number 3. Right? So all the constant terms are on the right hand side. So it's okay. Okay? So now let, what is capital A here? It is 1, minus 1, 0, you know that. 2, 3, 4 and 0, 1, 2. Is that clear? 1, minus 1, 0, 2, 3, 4, 0, 1, 2. These are the coefficients of x, y and z from the first, second and the third equations. And then let, what is capital X? It is the unknown matrix, that is column matrix x, y, z. And let, what is capital C here? Capital C is the constant matrix, that is 3, 17 and 7. It is 3, 17 and 7. Okay. So now these linear equations are converted to what? Matrix equation. So what is the matrix equation here? AX is equal to C. That means what is X is equal to? A inverse C. So now you know how to write A inverse C. So here capital X is equal to, what is A inverse? You have to write down A inverse. What is A inverse here? We just determined A inverse, that is 1 upon 6. 1 upon 6. So it is 2, 2, minus 4, minus 4, 2, minus 4, and then 2, minus 1, 5. So this is your A inverse. And what is C? Dot C, what is dot C? Dot C is 377. 377. This is your column matrix. So now, therefore, capital X is equal to 1 by 6. Now multiply these two matrices. So first row by first column. Corresponding elements should be multiplied. So 3 2s are 6, plus 7 2s are 34, minus 28. Right? Again, second row by first column, minus 4 into 3, minus 12, plus 7 2s are 34, minus 28. Minus 28. Right? Next one is third row by first column. What is it? 3 2s are 6, minus 17, plus 7 5s are 35. Right? or capital X is equal to 1 by 6. Now simplify it. This is 40 minus 28. This is 34 minus 40, right? Next one is 41 minus 17. That is 35 plus 6 is 41 minus 17. Okay? So now next, or capital X is equal to 1 by 6. 1 by 6, what is 40 minus 28? That is 12. What is 34 minus 40? Minus 6. What is 41 minus 17? 24, right? Right, that is 24. Now, what is capital X here? Actually, it is XYZ. So, which is equal to, now this matrix, all the elements in this matrix is multiplied by the scalar quantity 1 by 6. What is 1 by 6 into 12? That is 2. 1 by 6 into minus 1. Oh, sorry, 1 by 6 into minus 6, that is minus 1. 1 by 6 into 24 is 4. So now from the definition of the equality of the two matrices, you can equate the corresponding elements. That means what do we get? X is equal to 2, Y is equal to minus 1, and what is Z? That is Z is equal to 4. So this is the final answer. So I think you have understood it. Using the product of the two given matrices, we have solved the given system of equations. So this is the method for solving this kind of equation. Okay. So this much is for today. So you revise all the problems that we did today, and in the next class we'll do more problems. Okay.